In this tutorial, we are going to talk about even and odd functions. So let's start with even functions. The definition of an even function is if you take f of negative x, you plug negative x into your function f. If you get out the same output or function as f of x, then you have an even function. And this is going to make more sense once you see some examples. So if we look at this graphically, what an even function does is it has symmetry about the y-axis. And we know that that basically means that both sides of the y-axis are mirror images of each other. So if we talk about the function f of x equals x squared, this is an even function. So if we were to graph that function, if you don't know what it looks like, you could make a table of values, but if you plug in 0, you get out 0. If you plug in 1, you get out 1. 2, you get out 4. 3, you get out 9. And here's the key here. What makes this as an even function is if I plug in negative 1, I get out 1, right? This is a mirror image of when I plugged in 1. So when I plugged in 1 and got out 1, and I plugged in negative 1 and got out 1, the fact that these y values are the same, whether or not I plugged in the positive or negative version of 1, that's what makes this have that symmetry about the y-axis. Or when I plug in negative 2, I get positive 4. Again, if I plugged in 2, I got out 4. But if I plugged in negative 2, I got out 4. So plugging in the positive or negative version of the same number gets us the same y value. So plugging in negative 3, you get out 9. We have this symmetry about the y-axis. The left side and the right side are mirror images of each other. So if AB is on the graph, then so is negative AB. So again, this is saying if you plug in a negative x value and you plug in a positive x value, your two outputs are equal to each other. So in this case, if you wanted to, you could prove this algebraically. And what we would do is we would actually plug negative x into the function. So f of x equals x squared. So my input value is negative x, which means I'm taking negative x and squaring it. Well, I know squaring negative x means negative x times negative x. Well, a negative times a negative is positive, and x times x is x squared. So when I plug in f of negative x, I get out x squared, which is the same thing that you get when you plug in f of x, right? That is the same function. So the fact that f of x equals f of negative x, they equal each other, then this is going to be an even function. And we already talked about if the point 2, 4 is on the graph, then the point negative 2, 4, its reflection over the y-axis, is also on the graph. So these are just some ways to check if something is an even function. So let's talk about odd functions. Odd functions are going to look a little bit different graphically. The definition of an odd function is if you take the negative x value and plug it into your function, then you get out the negative value of f of x. And I'll show you again what this means algebraically. Graphically, though, an odd function is still going to have symmetry, but this type of symmetry is going to be rotational, and it's going to be about the origin. So this is rotational symmetry. This means that the graph essentially rotates 180 degrees counterclockwise about the origin. So let's look at an example, and then we'll talk about this last line here. G of x equals x cubed. This is going to be an odd function. So if we're not sure what it looks like, just plug in some values. If I plug in 0, 0 cubed is 0. 1 cubed, well, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. So this side of the function is going to look kind of like half of a parabola. It's not parabolic technically, but it looks like it. But what if I plug in negatives? Well, negative 1 cubed, think of negative 1 times negative 1 is 1, times negative 1 again is negative 1. So I get an output of negative 1. So compare that. When I plugged in 1, I got 1. But when I plugged in negative 1, I got negative 1. So we'll keep that in mind when I plug in 1 versus negative 1. If I plug in negative 2, I'm going to get out negative 8 because negative 2 times negative 2 is 4, times negative 2 again is negative 8. So your function looks something like this. So let's compare that. When I plugged in 2, I got 8, but when I plugged in negative 2, I got negative 8. So when I plugged in the positive version versus the negative version, my outputs were also opposites of each other. So that means that if I were to plug in if I plug in A and I get out B, well, if I plug in its opposite, so if I plug in negative A, so here, when I plugged in its opposite, I got the opposite y value, which means we would get out negative b. So if we have g of negative x and we're trying to prove that this is odd algebraically, then we would say, well, technically what we're doing is negative x cubed. We plug that negative x value into our function. Negative x cubed is negative x times negative x times negative x. Well, if I take that and multiply those out, this is like a negative times a negative is a positive times a negative. I'm going to get a negative answer, and x times x times x is x cubed. So comparing x cubed, my output here, versus this output, the opposite of x cubed, they are opposites. So that means g of x is equal, g of negative x, this value here, is equal to the opposite of g of x, and that's our definition. So these are going to be, this is going to be an odd function. If the point 2, 8 is on the graph, then again, the opposite points would exist on an odd function. So negative 2, negative 8. So what can we do if we're given a function and asked to determine if it's even, odd, or neither? You can do one of two things. One option is you could take this and plug it into your calculator and look at it graphically. If it's symmetric about the y-axis, then we know it's even. If it has rotational symmetry about the origin, then we know that it's odd if that rotation is 180 degrees. And if it doesn't have either, then it's neither. Another option, though, is you would just take the function and plug in negative x. So for all of these, we're going to work on plugging in negative x, and then we're going to compare back to the original function. So if we find g of negative x, so we plug negative x into this function, that would be negative x squared minus 2 times negative x minus 2. Well, negative x times negative x is going to be a positive x squared. Negative 2 times negative x is a positive 2x, and then we have minus 2. So what we want to do is compare. Did we get the exact same thing? Because if we got the exact same thing, they would be even, right? Because that would imply that g of x would equal g of negative x. But these aren't the exact same. So are they opposites? Meaning, is every term over here its opposite over here? Well, x squared, they're not opposites. Negative 2x, positive 2x, those are opposites. And the negative 2 and negative 2 aren't. So since the whole thing isn't opposites, it's also not odd, because we're not saying that this, the opposite of this, is g of negative x. So in this case, this is going to be neither. We have this function, h of x cubed over 4 minus x squared. So if we evaluate h of negative x, we plug negative x in. So negative x cubed over 4 minus, negative x squared. Well, negative x times negative x times negative x is going to be negative x cubed, or the opposite of x cubed, over 4 minus, negative x times itself is going to be x squared. So you're subtracting a positive x squared. So does this match this exactly? It does not. Is it the opposite of each other? Well, think about if you have 2/3 versus negative 2/3. They are opposites because the negative can be on top or on bottom or out front. So x cubed over 4 minus x squared versus the opposite of x cubed over 4 minus x squared. This is showing me that these two are opposites. So since they are opposites, h is going to be an odd function. Lastly, let's look at I. F of x. So if we want to take f of negative x, that means we are going to take the square root of negative x, the quantity squared, plus 2. Well, squaring negative x is going to give us a positive x squared plus 2. So when I plugged in negative x, I got the exact same output as when I plugged in positive x, right? These two functions end up matching each other. So that means that since these match each other, this is going to be an even function.